National Electrical Code Article 250.24. A5 addresses the requirement for a neutral conductor in certain panel boards. This section is found within the broader context of grounding and bonding requirements for electrical systems. Understanding the specific stipulations outlined in 250.24. A5 is crucial for ensuring electrical safety and code compliance. Article 250.24. A5 specifically focuses on the presence of a neutral conductor in service panels, lighting panels, and distribution panels. This requirement is not universally applicable to all panel boards but is instead contingent upon the voltage and phase configuration of the electrical system. The code explicitly mentions 3 specific voltage and phase configurations where a neutral conductor is mandatory. Firstly, panel boards rated 120/240 volt single phase are required to have a neutral conductor. This configuration is commonly found in residential and small commercial applications where single phase power is utilized. Secondly, panel boards rated 120/208 volts 3-phase Y are also required to have a neutral conductor. This configuration is typical in commercial and industrial settings where 3-phase power is distributed with a Y connection. Thirdly, panel boards rated 240 volts 3-phase delta are also included in the requirement for neutral conductor. This configuration is less common than the 120/208 volts 3-phase Y, but is still encountered in some industrial applications. The rationale behind mandating a neutral conductor in these specific panel board configurations is rooted in safety and fault current management. A neutral conductor provides a low impedance path for fault current to return to the source, facilitating the rapid operation of overcurrent protective devices such as circuit breakers or fuses. Without a neutral conductor, fault current may find alternative and less predictable paths to ground, potentially leading to elevated voltage on conductive surfaces, increased risk of electric shock, and delayed clearing of faults. The presence of a neutral conductor ensures that fault currents are effectively channeled back to the source, minimizing the duration and magnitude of fault conditions. This enhances the overall safety of the electrical system and reduces the likelihood of electrical hazards. It is important to note that the requirement for a neutral conductor in 250.24. A5 is in addition to the requirements outlined in 250.24. A4. Article 250.24. A4 addresses the grounding of the neutral conductor itself, ensuring that it is properly connected to the grounding electrode system. The combination of 250.24. A4 and 250.24. A5 ensures that the neutral conductor is both present and properly grounded, providing a comprehensive approach to grounding and fault current management. The requirement for a neutral conductor in 250.24. A5 is not merely a theoretical concern but has practical implications for electrical installations. When designing and installing electrical systems, it is crucial to verify the voltage and phase configuration of the panel boards being used. If the panel board falls under one of the 3 configurations specified in 250.24. A5, then a neutral conductor must be provided. Failure to comply with this requirement can result in code violations, safety hazards, and potential liability. The size of the neutral conductor is also an important consideration. The National Electrical Code provides guidelines for sizing the neutral conductor based on the anticipated load and the type of system. In some cases, the neutral conductor may be required to be the same size as the phase conductors, while in other cases, a reduced size may be permitted. It is essential to consult the applicable code sections and tables to determine the appropriate size for the neutral conductor. In addition to the sizing requirements, the installation of the neutral conductor must also comply with other code provisions. The neutral conductor must be properly insulated, protected from physical damage, and terminated in accordance with the manufacturer's instructions. Proper termination is crucial to ensure a reliable electrical connection and to prevent overheating or arcing. It is also important to note that the neutral conductor must be kept separate from the equipment grounding conductor. The equipment grounding conductor provides a path for fault current to return to the source in the event of a ground fault, while the neutral conductor carries the unbalanced current under normal operating conditions. Mixing the neutral conductor and the equipment grounding conductor can create a ground loop, which can result in unwanted current flow and potential safety hazards. The National Electrical Code specifies the conditions under which the neutral conductor and the equipment grounding conductor can be connected together. In general, these connections are only permitted at the service entrance or at separately derived systems. In all other locations, the neutral conductor and the equipment grounding conductor must be kept separate. The enforcement of 250.24 A5 is typically carried out by electrical inspectors who review electrical plans and conduct on-site inspections. During these inspections, the inspector will verify that the panel boards are properly rated, that a neutral conductor is present when required, and that the neutral conductor is properly sized and installed. Failure to comply with 250.24 A5 can result in the rejection of the electrical installation and the requirement for corrective action. In conclusion, National Electrical Code Article 250.24 A5 mandates a neutral conductor in specific panel board configurations to enhance safety and facilitate fault current management. This requirement applies to 120/240 volt single-phase, 120/208 volts 3-phase Y, and 240 volts 3-phase delta panel boards. Compliance with 250.24 A5 is essential for ensuring electrical safety and code compliance. The information provided here is for general guidance only and should not be considered a substitute for professional electrical engineering advice. Always consult with a qualified electrician or electrical engineer for specific design and installation requirements. Let's delve deeper into the technical aspects and implications of NEC Article 250.24 A5. This code section is not just a simple requirement, it's a cornerstone of electrical safety, particularly in ensuring effective fault current paths in specific electrical systems. When we talk about the 208 volts 3-phase system, it's crucial to understand its configuration. Typically, a 208 volt system is a 3-phase Y system derived from a 480 volts 3-phase Y system through a step-down transformer. The Y configuration implies a neutral point, which is the common point of the 3-phase windings. However, not all systems utilize this neutral. Article 250.24 A5 comes into play when you're feeding a panel board from a 208 volts 3-phase source, especially if the panel board is designed to serve 120 volts loads. The 120/208 volts designation indicates that the panel board can supply both 208 volts 3-phase power and 120 volts single-phase power by utilizing the neutral conductor. The absence of a neutral in such a panel board can lead to significant safety concerns. Without a neutral, single-phase loads connected to the panel board would not have a proper return path. This can result in elevated voltage on equipment cases, creating a shock hazard. Furthermore, in the event of a ground fault, the fault current may not have a clear path back to the source, potentially delaying the operation of overcurrent protective devices. The requirement for a neutral is particularly important in panel boards serving lighting circuits. Lighting circuits often include sensitive electronic ballasts or drivers, which are susceptible to voltage fluctuations and transients. A properly grounded neutral helps to stabilize the voltage and reduce the risk of damage to these components. Now let's consider the 240 volts 3-phase delta system. In a delta system, there is no inherent neutral point. However, a 250.24 A5 still mandates a neutral conductor in certain 240 volts 3-phase delta panel boards. This is typically achieved by creating a center tap delta configuration. In a center tap delta system, one of the phase windings is grounded at its midpoint. This creates a neutral point that can be used to supply 120 volts single-phase loads. Similar to the 120/208 volts Y system, the absence of a neutral in a center tap delta panel board can lead to safety hazards and equipment damage. The neutral conductor in these systems is not just for providing a return path for single-phase loads, it also plays a crucial role in limiting voltage imbalances and reducing harmonic distortion. Voltage imbalances can occur when the loads on the three phases are not evenly distributed. This can lead to overheating of motors and other equipment. A properly grounded neutral helps to mitigate voltage imbalances by providing a low impedance path for current to flow between the phases. Harmonic distortion is another common problem in electrical systems, particularly those serving nonlinear loads such as electronic equipment. Harmonics are unwanted frequencies that can cause overheating of transformers, conductors, and other equipment. A neutral conductor can help to reduce harmonic distortion by providing a path for the harmonic currents to flow back to the source. The size of the neutral conductor is a critical factor in ensuring its effectiveness. The National Electrical Code provides guidelines for sizing the neutral conductor based on the anticipated load and the type of system. In some cases, the neutral conductor may be required to be the same size as the phase conductors, while in other cases, a reduced size may be permitted. For example, in a system serving primarily nonlinear loads, the neutral conductor may need to be oversized to accommodate the harmonic currents. It's also important to consider the ampacity of the neutral busbar in the panel board. The neutral busbar is a conductive bar that serves as the termination point for the neutral conductors. The ampacity of the neutral busbar must be sufficient to handle the maximum anticipated neutral current. In addition to the sizing requirements, the installation of the neutral conductor must also comply with other code provisions. The neutral conductor must be properly insulated, protected from physical damage, and terminated in accordance with the manufacturer's instructions. Proper termination is crucial to ensure a reliable electrical connection and to prevent overheating or arcing. The connection between the neutral conductor and the grounding electrode system is also critical. The grounding electrode system consists of various grounding electrodes, such as ground rods, metal water pipes, and building steel, that are interconnected to provide a low impedance path to ground. The neutral conductor must be connected to the grounding electrode system at the service entrance or at separately derived systems. This connection ensures that the neutral conductor is at or near ground potential, which helps to reduce the risk of electric shock. It's important to note that the neutral conductor and the equipment grounding conductor must be kept separate throughout the distribution system, except at the service entrance or at separately derived systems. The equipment grounding conductor provides a path for fault current to return to the source in the event of a ground fault. If the neutral conductor and the equipment grounding conductor are connected together at multiple points, it can create a ground loop which can result in unwanted current flow and potential safety hazards. The enforcement of 250.24 A5 is typically carried out by electrical inspectors who review electrical plans and conduct on-site inspections. During these inspections, the inspector will verify that the panel boards are properly rated, that a neutral conductor is present when required, and that the neutral conductor is properly sized and installed. Failure to comply with 250.24 A5 can result in the rejection of the electrical installation and the requirement for corrective action. From a practical standpoint, when dealing with an existing 208-volt three-phase motor control center, adding a panel board downstream requires careful consideration of the grounding and neutral requirements. If the motor control center does not have a neutral conductor, it may be necessary to install a separately derived system such as an isolation transformer to create a neutral point for the panel board. The isolation transformer would provide a neutral conductor that can be connected to the grounding electrode system. Alternatively, it may be possible to run a neutral conductor back to the service entrance where the neutral is already grounded. However, this option may not be feasible or cost-effective in all situations. In summary, NEC Article 250.24 A5 is a critical code section that mandates a neutral conductor in specific panel board configurations to enhance safety and facilitate fault current management. This requirement applies to 120/240 volts single phase, 120/208 volts three-phase Y, and 240 volts three-phase delta panel boards. Compliance with 250.24 A5 is essential for ensuring electrical safety and code compliance. When designing and installing electrical systems, it's crucial to consult with a qualified electrician or electrical engineer to ensure that all applicable code requirements are met. The absence of a neutral where required is not just a technical oversight, it's a potential safety hazard that can have serious consequences. Proper grounding and bonding are fundamental principles of electrical safety, and 250.24. A5 plays a vital role in ensuring that these principles are upheld.